Hello learners, welcome once again. We are looking at the chapter 2 of Form 2 chemistry, that is chemical families. So in our part 1 we looked at the physical properties of alkali metals, and today we are going to look at the chemical properties of alkali metals. So if you find this video helpful, please remember to like and to subscribe so that you can get notified once other videos are uploaded. So the chemical properties of alkali metals, the first one, we are going to begin with the reaction of alkali metals with air and oxygen. So remember, we are looking at the first three elements in the group 1, that is lithium, sodium, and potassium. So how do these metals react with air, or how do they react with oxygen? So we begin by looking at lithium. Lithium burns in oxygen with a deep red flame. We call it crimson flame to form a white solid. So it burns with a deep red or a crimson flame to form a white solid. This is because lithium reacts with oxygen to form lithium oxide, which is a white solid. You can see the reaction there. So we have lithium metal plus oxygen gas to form lithium oxide. That is a white solid. What about sodium? So what happens when sodium burns in oxygen? So sodium burns in oxygen with a yellow flame. So underline that. So sodium burns with a yellow flame to form a white solid, that is sodium oxide. So you can see the reaction between sodium and oxygen. So sodium plus oxygen will give us sodium oxide, which is a white solid. The equation is balanced and the state symbols are okay. So you can see we have 4 sodium, we have 2 times 2, that is 4. We have 2 oxygen on this side and we have 2. So the equation is balanced. So also sodium burns in excess oxygen to form sodium peroxide. So this is the formula of sodium peroxide. This is sodium reacting with excess oxygen to form sodium peroxide. What about potassium? What happens when we burn potassium in oxygen? So potassium burns in oxygen with a lilac flame. So the flame that we see when we burn oxygen is what we call lilac flame to form a white solid. So also potassium forms a white solid. The white solid is potassium oxide, and that is the reaction between sodium and potassium and oxygen to form potassium oxide. The state symbols and the equation should be balanced. So that is how alkali metals react with, or what we observe when we burn alkali metals in oxygen. So let us look at the second chemical property. This is the reaction with chlorine. So what happens when we react our group 1 elements with chlorine? We start by looking at lithium. So when hot lithium, remember we are using hot, is lowered in a gas jar containing chlorine, it continues to burn with a deep red flame to form a white solid. So this white solid that is being formed is lithium chloride. So here's the reaction between lithium and chlorine to form lithium chloride. So the symbols, the state symbols, the balancing, the equation is correct. What about sodium? So what happens when sodium reacts with chlorine? So we say when hot sodium is lowered in a gas jar containing chlorine, it burns into a flame and a white solid is formed. So it bursts into flame and it forms a white solid. So this white solid is sodium chloride. So the reaction between sodium and chlorine is as shown below, sodium plus chlorine to form a solid known as sodium chloride. that is a solid. That is why we are using the symbol S. Then we look at potassium. Potassium metal bursts into flame when lowered in a gas jar containing chlorine, and it also forms a white solid, that is potassium chloride. So here's the reaction: potassium plus chlorine to give us potassium chloride. The balancing we put to where we have potassium and also to before potassium chloride. So that is the balancing of that equation. So alkali metals reacts with chlorine to form metal chlorides, that is lithium chloride, sodium chloride, and potassium chloride. The next property, or the next chemical property of alkali metals we are looking at, is the reaction with water. So what happens when these metals react with water? We had looked at this previously in a topic in Form 1, that is water and hydrogen. So we have little knowledge on this, but so let's look at what happens when these metals react with water. So lithium floats on water. This is due to its low density. It floats on water because it has a low density, and it also produces a hissing sound. So this hissing sound means there's production of a gas, and the gas being produced here, we know it's hydrogen gas. So lithium floats on water, producing a hissing sound due to the production of hydrogen gas. An alkaline solution is formed. So this alkaline solution is lithium hydroxide. So down here we have the reaction between lithium and water to give us lithium hydroxide and water. So lithium hydroxide is what we are saying, it is an alkaline solution. So the reaction is as shown and the correct balancing. Then sodium also floats on water, that is because of its low density. Then sodium darts on water. So as we do an experiment, we will see sodium darting on the surface of water because hydrogen gas produced propels it sideways. So that is the reason sodium darts in water. It's because the hydrogen gas produced propels it sideways. Then sodium melts into a silvery ball. This is because the reaction between sodium and water is exothermic, meaning that it is releasing energy. So this is what makes sodium form a silvery ball as the reaction takes place. There's production of a hissing sound also due to the production of hydrogen gas. So we said metals react with water to produce hydrogen gas. So we shall also hear the hissing sound. And also an alkaline solution is formed. So this alkaline solution is sodium hydroxide. We have the reaction here between sodium and water. So sodium is a metal, so solid, plus water, it's a liquid, to give us sodium hydroxide and hydrogen gas. Potassium floats on the surface of water because also it has a low density. Potassium darts on water surface because hydrogen gas also propels it sideways, as we have seen for sodium. Then potassium vapor burn with a lilac flame because hydrogen gas produced bursts into flame, which ignites the potassium. And also we form an alkaline solution of potassium hydroxide. So the reaction is here between potassium and water to give us potassium hydroxide and hydrogen gas. So that is the reaction between the alkali metals and water. to form the hydroxides and the hydrogen gas. The next part we are going to look at is the uses of alkali metals. So we look at six uses, but there are more other uses of alkali metals. So the first one is sodium. So sodium is used in the manufacture of sodium cyanide, used in extraction of gold. Lithium is also used in the manufacture of glasses. Sodium vapor is used to produce the yellow glow in street lamps or street lights. Sodium chloride is used in food additives, and sodium nitrate and potassium nitrates are used as fertilizers. Sodium carbonate, or what we call the washing soda, is used to soften water and in the manufacture of chemicals. So these are just some of the uses of alkali metals. There are so many uses. So I have just highlighted 6 of them. Then here we have some questions. So we have questions that you can always be tested, and you should be able to answer this question from this topic. So for example, we have define alkali metals and provide 3 examples. Explain why alkali metals are highly reactive. Discuss the trend in reactivity of alkali metals as you move down the group in the periodic table. Describe the reaction of alkali metals with water, including the observations you would make during the reactions. Compare and contrast physical properties of alkali metals with those of alkaline earth metals. Alkaline earth metals are group 2 elements. Why are alkali metals stored under oil or inert gases? Discuss the uses of alkali metals in everyday life and industry. Explain why alkali metals are never found in the elemental form in nature. Discuss the health and safety precautions that you should take when handling alkali metals in the laboratory. So you make sure you can pause this video and answer these questions. So before you proceed to listening, you can maybe pause and try to answer them. For me, I'm going to answer the first 3 or 4 questions. So we have the answers here for the first questions. So for example, we have define alkali metals and provide 3 examples. So as we have learned, alkali metals are a group of chemical elements found in group 1 of the periodic table. We said they are very reactive metals. They have 1 electron in the outermost energy level, or we call it the shell, in the outermost shell or the outermost energy level. Examples are lithium, sodium, and potassium. So these are the first 3 elements in the group 1. Then the second question is you explain why alkali metals are highly reactive. So we said alkali metals are highly reactive because they have 1 electron in the outermost energy level. That is, they have 1 delocalized electron, which they readily lose to form positive ions. The loss of electron allows them to achieve a stable noble gas configuration, resulting in increased reactivity. So the presence of the 1 delocalized electron in the outermost energy level makes them to be very reactive. Question 3, you discuss the trend in reactivity of alkali metals as you move down the group in the periodic table. So the reactivity of alkali metals, we saw that it is increasing as you move down the group in the periodic table. This is because of the decrease in ionization energy, or the decrease in energy required to remove that 1 electron from the outermost energy level, and also the increase in the atomic size As a result, the outermost electron is further away from the nucleus and experiences weaker attraction, making it easy to lose and hence increasing reactivity. So that was well explained. Then describe the reaction of alkali metals with water. So what happens? This is what what we have just looked in this lesson. So we said for the reaction of alkali metals with water, they react very vigorously with water. They produce hydrogen gas and they form metal hydroxide. Then the reaction becomes more vigorous as you move down the group. For example, uh, that of potassium is more vigorous. The reaction between water and potassium is more vigorous than the reaction of water, the reaction between water and lithium. So it becomes more vigorous as you move down the group, meaning they are more reactive. Potassium is more reactive than lithium, so its reaction with water will be more vigorous. So those are the answers I am going to provide. So make sure you answer the rest of the questions. And if there will be any challenge, you can communicate or you can comment in the comment section. So as for today, that will be our part 2 of the topic or the chapter 2, chemical families. So let us now meet again as we look at the group 2 elements, or what we call the alkaline earth metals. So till next time, have a nice time.